Now, you and I, we were talking about alkanes, right? Now, for alkanes, we had discussed that alkanes are organic compounds. You can say organic compounds, or you can also consider them to be hydrocarbons. Hydrocarbons are, we had discussed, hydrocarbons are compounds that have both carbon and hydrogen, right? That's it. They will only have carbon and they will only have hydrogen. Any other atom, oxygen, nitrogen, sulfur, it won't have any of that. The only thing it will have is one carbon and second hydrogen. So alkanes are hydrocarbons that have a single covalent bond between the carbon. That's the definition that we had discussed. Then we had talked about naming of the alkane. And in naming of alkanes, we had said that whenever we're naming a organic compound, okay, we will have a prefix and we will have a suffix, right? That's what we had discussed. Now, the when we're going to talk about it, so we are going to be naming the alkanes based on the number of carbon atoms. So, for example, if I have just one carbon atom, that's methane. Then, if I have two carbon atoms, that's methane. If we have three carbon atoms, that's propane. Now, one thing that we're going to, again, we had discussed this previously as well, that if you see that between the carbon atoms, we only have one single bond. When I say single bond, what do we mean by single covalent bond? By single covalent bond, I mean that the carbon atoms are sharing one pair of electrons, right? That's what we mean by a single covalent bond. Okay, so in alkanes, between the carbon atoms, we have a single covalent bond. Now, each carbon atom, so when you're drawing the structure, okay, in the exam, when they ask you to make the structure, whenever you're drawing the structure, you have to remember that carbon can have up to 4 bonds. Okay, a carbon atom makes 4 bonds. So, in this situation, for example, if I have one carbon atom, right? This one carbon atom is going to make a bond with 4 hydrogen atoms. That's one thing whenever you're making a structure, this is how you're going to make it. Always make sure that carbon has 4 bonds. Again, in this particular case, you can see carbon is making 4 bonds. One over here, 2, 3, 4. Similarly, this carbon is also making 4 bonds. Again, this is 1, 2, 3, 4. Right? Now, you see the formula that the way I have written down the formula like this, all open. You can see exactly how the carbon is bonded to hydrogen, how the carbon is bonded to itself. You can see all of that, right? This type of a formula is known as a displayed formula. Right? Another way of writing down the formula is like this. So methane can be CH4 because we have one carbon atom and four hydrogen atoms. Methane will be C2H6. Propane is going to be C3H8. Exactly. This sort of a formula that I have just written down, we call it a molecular formula. So the reason I'm specifying the difference between the two of them is in the exam questions, they often specify. They will say, tell us what is the molecular formula or give the displayed formula. That's very important. Okay. So you always have to read in the question what kind of formula are they asking and then give the appropriate formula. Right? Now, when when we are talking about our alkanes, so in the topic of alkanes, this is just a revision of what we had covered previously. Now, when we talk about our alkanes, in every single topic that we do in organic chemistry, we're going to divide it in two ways. Okay? In fact, three ways. Number one, we are going to talk about the structure. So first thing that we're going to cover is the structure of the organic compound. The second thing that we will cover are the physical properties and then the chemical reactions. Okay. So the structure you and I had already covered in the last class. Now, let's take a look at some physical quantities. Okay. Now, when we talk about physical quantities, again, revision of something that we had covered previously as well, when we had, if you remember, we had said, right, that in our organic compounds, in our organic chemistry, we have alkanes, we have alkenes, we have alcohols, we have carboxylic acids. So all of these are different groups. I told you that in organic chemistry, we don't use the term groups. We use the term homologous series, right? That's what we discussed. And in a homologous series, you will get questions where they will ask you that how do you know that these compounds are from the same homologous series? Or what are the features of a homologous series? So there are three features that you are going to say. Feature number one, they all follow the same general formula, or they all have the same general formula. Point number two was that they all follow the same physical trend. And point number three is they all have similar chemical properties, right? So any compounds that have the same general formula, they follow the same physical trend, the pattern in their physical properties. The compounds follow that pattern. They fit in with the pattern and they have same chemical properties. Any compound that follows these three features, we can classify that compound to be in the same homologous series. So, in the case of alkanes, the general formula was CnH2n plus 2.
That's for
Right?
alkane.
That's for alkane, exactly. Yeah. This is specifically for alkanes. Similarly, when we are going to talk about alkenes, they will have a different general formula. Carboxylic acids, different. Alcohols, different. So every
What do we
homologous,
call this formula?
I'm telling you. I'll explain the formula in 1 second. But this is the general formula for alkenes, right? As soon as we change the series, as soon as I go from alkenes to alcohols to carboxylic acids, the formula will change. Okay. So in a homologous series, all the compounds, so all the alkanes will follow the general formula. Now let me explain this formula to you. The formula works like this. The N stands for number of carbon atoms. So let's see, you have 4 carbon atoms, okay?
Mhm.
What are you going to do? Wherever you have N, you will write down 4. C4, H2. Now, we're not going to write down N, we're going to write down 4 plus 2. We get C4H. Yes, 2 4s are 8 plus 2, 10. So you know that if I ask you to make an alkane with 4 carbon atoms, it's going to have 10 hydrogen atoms. So this is a general formula. You can choose any number of n, right? Number of n. You will see that all the molecular formula of all the compounds follow this pattern. This pattern will fit on any alkane. You open up any alkane, this will always be the ratio of carbon and hydrogen. Okay? So this is known as a general formula. If you know the general formula, so even if I ask you, Viraj, can you make the structure of alkane with 20 carbon atoms? You won't have to worry about figuring it out. All you do is you put the number 20 over here, right? You put the number 20 over here and you get C20 H20 H2 into 20 plus 2. So your formula comes out as C20 H. 2 20s are 40. 40 plus 2 is 40. There you go. So you will just draw 20 carbon atoms and 42 hydrogen, right? That's the purpose of the general formula. So it doesn't matter how many carbon atoms I give you. You can just put the number in the formula and you will always know the structure of the alkane. Right? So far, all clear?
Yeah.
Perfect. Now, this was the first property that they all have the same general formula.
But I have a question though.
Yes, go on.
Like you said that the for alkanes, right? Alkanes are organic compounds that have a single covalent bond between the
Yes.
carbon atoms, right?
Yes. Yes.
Like for methane, right? There's only like one carbon. So like, how does it have a covalent bond between hydrogens?
Oh, single covalent bond. With hydrogen, it is single covalent bond. Okay.
Oh, hydrogen has single bond. Okay.
Yeah, it will. The thing is, okay. So let me just elaborate on that. Why is it necessary that in the exam you write down that it has a single covalent bond between the carbon atoms? The reason for that is because after alkenes, we will study alkenes. Okay.
Mhm.
So in alkenes, the carbon atoms have double covalent bond. Okay. With hydrogen, the covalent bond is always single. And you and I can figure out a reason for that. Let me explain to you. Why exactly is it that with carbon atoms, we always have a single covalent bond? Why can't we have a double? You can always figure it out by drawing a dot and cross diagram. Carbon is in group number 4. So it has got 4 electrons in the outer shell.
Yeah.
Hydrogen is in group number 1. In fact, if you open the periodic table, you will see hydrogen only has 1 electron, right?
Electron. Yeah.
So exactly. So there is
so
no
there's a-
possible way. Yeah, there is no possible way for hydrogen to share 2 pair of electrons, right? It can only maximum pair of electrons it can share is 1. That's why with hydrogen it is automatically understood, right? Like it's like understood. It will have a single covalent bond. There is no other option. But between 2 carbon atoms, there is a possibility of a double covalent bond, right? So that's why in the definition we specify that when we are talking about the single covalent bonds, it has to be the single covalent bond between carbon atoms. Because with hydrogen, it doesn't matter which compound it is. With hydrogen, it will always be single. That's why we're specifying. Okay?
Yeah.
Perfect. Okay. Now, after this, another important thing that we have to look at. So the second, in our homologous series, what's the second thing? The second thing is that they all have the same chemical, they all have the same physical trend. Now, let's elaborate on this. Let's talk about the fact that they all have the same physical trend. Okay, what is the trend? What do we see? So, the physical trend sort of looks like this. Okay, the physical trend looks like this. Now, in the homologous series, you are going to see as we go down the homologous series of alkanes, the boiling point and melting point increases. Okay, so the boiling point and the melting point increases. There is a reason for this. The reason for this is that now if I am going down the chain, let me explain what we mean going down the chain or going down the homologous group. Okay, this is what I mean by this. If I start from CH4, C2H5, sorry, H6, C3H8, C4H10, C5H12. So, as I'm going to go down the series, I'm going to see that the boiling point and the melting point is going to increase. Now, what is the reason for this? The reason for this is that as I go down, the number of carbon atoms are increasing, right? You can see that the number of carbon atoms are increasing. The carbon chain, we use the term carbon chain, right? Because it's like a chain of carbon atoms. So the chain of carbon atoms is getting longer and longer and longer and longer, right? So the molecule is getting larger and larger and larger and larger. So if I want to break these bonds, I am going to need more energy. In methane, I only need to break 4 bonds. In propane, I need to break 6, 7, 8, almost 8, right? In propane, I need to break, in fact, 10, sorry, 2 between the carbon atoms as well. In propane, I need to break up to 10 bonds. So to break the bonds of propane, I need more energy. To break the bonds of methane, I need less energy. So as you go down the chain, the boiling point and the melting point should increase, right? And if any molecule does not follow this trend, for example, you have discovered a new molecule, fine, and you and I are debating where should we put it in the organic chemistry, like what compound should it be? So for me to include it as an alkane, it should follow the trend, meaning that if it has got 3 carbon atoms, so it should have a boiling point that is higher than methane. If it has 3 carbon atoms, but the boiling point does not fit the trend, it does not fit the pattern, then it can't be considered a part of the series, right? So it should, the boiling point and the melting point will increase. Then, if we continue talking about the physical trends, point number 2, the state changes from gas to liquid, right? These 3, one second, just if we talk about these 4, okay, if we talk about these 4, from methane, ethane, propane, butane, these 4 are all gas at room temperature. But after that, when we go below, if I go below pentane, hexane, heptane, octane, nocane, decane. As I go below, the state changes to liquid.
Liquid.
Yes. Again, this is due to the fact that the number of carbon atoms are increasing. Since the number of carbon atoms are increasing, so what is going to happen? That the molecules are going to come close to each other because the molecules are larger. So they're going to start to come closer to each other, right? And the state will change from gas to liquid. In gas, the molecules are far away. In liquid, the molecules are close together. So the state is going to change from gas to liquid. Now, when we talk about our density, okay, the density will also increase as we go down the group.
Wait, so the state changes from gas to liquid as we go down the group.
Yes, as we go down the group. Exactly. Right? As we go down the group, the state will change from gas to liquid. And specifically, you can actually be very specific about this answer. Up till butane, there are gases. After butane, we have liquids. Okay, so we have like that special point. Okay.
Yeah.
So these are some of the physical properties that you should know. Okay. Now, what is the third thing that you require for a homologous series? The third thing that you require for a homologous series is that they all have same chemical properties. What does that mean? That means that it doesn't matter if I take methane or ethane or propane, it doesn't matter. If I react them with the same chemical, they will give me the same result. Okay? Now, let me explain this. Let's talk about the chemical properties. Okay? When we are talking about the chemical properties, now, for each organic compound that you and I are going to study, because we're going to do alkenes and alcohols and carboxylic acids and esters, and then inshallah, when you do your A levels, you're going to do like, aldehydes, ketones, you're going to do your phenols, benzenes. So like in organic chemistry, keep in mind that the compounds we're studying this year, you will study a lot more than that when you do your A levels, right? So this is just going to keep on expanding. Now, when the thing about organic chemistry is that all of these compounds can be converted into each other. I can take an alkene and turn it into an alkane. I can take an alcohol and turn it into an alkene. I can take an alkene and turn it into an alcohol, right? That's the thing with
So,
organic chemistry. Yeah?
so can you like convert an alcohol into an alkene?
Yes, you can. You can take an
But,
alcohol, you can
but
convert
isn't
it.
an alkene and hydrocarbon though?
Yes, it is.
Like an
And that is,
alkene only has only hydrogen
OH.
and carbon, right?
Yes,
But like
it does.
alcohol might,
Alcohol, yes, it does. You are correct. You are correct.
but
Right?
alcohol has oxygen as well though.
If we react it with a specific chemical compound, we can remove the oxygen.
Uh,
Right? That's the thing. So in organic chemistry, not just this year, next year for A levels, this tip, and that's why I'm giving you this tip. That in organic chemistry, that this is one thing that the students struggle with. All the compounds can be turned into each other. Okay, you just have to react it with the correct compound, the correct chemical, and you have to give the correct conditions. Okay, like if you, for example, if heat is required, you have to use heat. In some reactions you need alcohol. In some reactions you need to add water. In some reactions it will only happen if you add the acid, right? So in organic chemistry, it's really important you use the correct chemical and you use the correct conditions. So what is going to happen that you can always convert them into each other. So that becomes difficult to remember, right? So when we finish the topic, right, like we finish all of organic chemistry, we will do one thing that we're going to stick together and we're going to make like flow chart, okay, together. And in that flow chart, we're going to, write down everything that this can be converted into this, and this is the chemical required for it, and that will make it easier for you to learn. So for every compound can undergo various chemical reactions. Okay. The good thing about alkanes is that alkanes, you only have to learn two reactions. One reaction is combustion.
Wait,
The
so
second
alkenes can only do combustion.
and substitution. That's it. Two reactions.
Wait, can you repeat what you said, please?
Yeah. Chemical. One second. Substitution. Yeah. Okay. So, when it comes to it can only take part in two reactions. One is combustion, and the other one is a substitution reaction. I'm going to teach you what that is. Don't worry. But combustion and substitution. That's it. Alkenes do not undergo any other reactions, which is good for us because we don't have to learn them. But there is a reason. There is a reason that alkenes do not have chemical reactions. For alkenes, we will study so many. For alcohols, we will study them. Why not alkenes? I will tell you that. But before I tell you that, let me go over combustion with you. Okay? Combustion is an exothermic reaction in which the alkane burns in air to produce carbon dioxide and right. The reaction is always going to look something like this. Let's take pentane. Okay, sorry, let's take butane, C4H10. If I take butane and I burn it in oxygen, so by burning, whenever I specify burn it in oxygen, that means that I need to provide heat energy, right? By the way, what is butane, methane, all of these alkanes that we're talking about, they come
Okay.
from crude. They come from crude oil, right? Crude oil is a fossil fuel. Your crude oil is a fossil fuel. Coal is a fossil fuel. Natural gas is a fossil fuel. So this is a fossil fuel, right? So just like if you have coal, what do you have to do with coal? You have to light them up. Similarly, if you have these gases, if you ever use your cooking cylinders, or if you ever go camping, you take your gas cylinder with you, right? So you always have to light it up. That's how it's going to start to react. So that's what we mean by burn in oxygen. Okay, so keep in mind, burn in oxygen and react with oxygen are slightly different. Burn in oxygen means that it will only react with oxygen when I provide some heat energy. Then you have already done these periodic table and all these topics before. That's why I'm talking about this. In periodic table, when you studied about sodium and potassium, you must have studied that they react very readily with air, right? Like sodium and potassium, if you leave them outside, they'll react with air like this, right? So that is reacting with air, okay? This is burning in air. A coal will not spontaneously start to react with oxygen. We have to light it. So if I take my butane and I react it with oxygen, I will always get carbon dioxide and water. Now, whenever you write the combustion equation, do remember you have to balance it out. The balancing is going to vary depending upon the number of carbon atoms and hydrogen atoms. So in this case, we have got 4 carbon atoms. So I will write down 4 next to the carbon dioxide, 10 hydrogen. So I will write down a 5 next to H2O. And we last have to balance the oxygen. So let's count the oxygen on the product side. On the product side, on this side, we have 13. 4 twos are 8 and 5, right? So this is going to become 8, 9, 10, 11, 12, 13. Just give me 1 second. 8 plus 5, 13. 13. Now, over here, I'm going to do you see how we're getting 13, okay? 13 oxygen. Now, how do we balance this? Can you think of it? How can I balance this? I'm getting 13 oxygen. Can you figure it out? How do I balance this?
Maybe we can add one more CO2, I think.
Add one, like we cannot just do plus CO2. That's not how we write the chemical.
Not like that, like 5 CO2 like that.
Okay, so if I make this 5 CO2, Now,
Yeah.
the number of carbon atoms over here are 5, but over here we have 4.
Yeah, that's so much.
That's a problem, right? I'll tell you. Do you want me to tell you a shortcut? I'll tell you a shortcut.
Yeah.
Okay. So what you do is we don't touch anything. Our carbon is balanced, our hydrogen is balanced. The only thing we have to change is oxygen. Carbon is done, hydrogen is done. We just have to balance the oxygen. How are you going to balance the oxygen? We want 13 oxygen. Okay. I want 13 oxygen. So what you do is that you write down 13 upon 2 O2. Right? 2 and 2 cancels out, you get 13 oxygen. Okay.
Yeah.
So you write down 13 upon 2 O2. Now, in A levels, this is actually how you're going to be doing it. You are going to be, if you write it down as 13 upon 2, your examiners will give you full marks. Okay? In A levels, we don't even bother making anything whole number. We can write it down as fractions.
What
But
about IGCSE?
in IGCSE, because it's easier for the students to write them down as whole numbers, so the examiners use whole numbers. Okay? So what are you going to do? I'll tell you a trick. You want to remove the 2 that's in the denominator, right? How will you remove the 2 in the denominator? Multiply the whole equation by 2. So what do you get? You get 2C4H10 plus 2 and 2 will cancel out. So you get 13O2 gives me 4 2s are 8 CO2 plus 5 2s are 10 H2O. Now everything will be perfectly balanced, right? And you and I will check it and make sure we are balanced. You always will, even if you use shortcuts especially. 8 carbon atoms, 8 carbon atoms. 2 tens are 20 hydrogen. 20 hydrogen.
Yeah.
8 twos are 16. 16 plus 10 is
26.
yes. And 13 multiplied by 2 is also 26. So it is balanced, right? Let me just do one more equation with you because the balancing of these equations is really important, right? Like that's where you will get confused in the exam. So let's go over one more. I'll tell you which one and you I want you to go ahead and try it out. So this was 2 and 13 and 8 and 10. Now, let's say that we have another equation. Let's say I asked you for C6H, 6 twos are 12, 13, 14. So what are the compounds? What will I get if I take this is hexane? Okay, by the way, 6 is hex. So if I react hexane with oxygen, what will be my compounds? What will be the product? Yes, that is fixed. That is fixed. We will always get carbon dioxide and water. Now, try to balance this. We will do this together. First, tell me, we have 6 carbon, so we write down 6. We have 14 hydrogen, so I'll write down 7. Fine. Now, look at the number of oxygen. How many oxygen do we have? Can you tell me?
19.
19, right? 6 twos are 12, 13, 14, 16, 17. Yes.
19,
so do first write down 19 upon 2. And now, because you want to remove the 2, so you multiply the whole equation by 2. So the equation becomes 2.
C6
Yes,
plus 19O2 by
yes.
12 CO2
Yes.
plus 14 H2O.
Yes, there you go. Equation is now balanced. That's it, we're done. Right? So this is what we meant by similar chemical properties. They will always give you carbon dioxide and water, but how much carbon dioxide, how much water, that can vary based on the compound.
Okay.
Now, the next reaction is substitution. Okay. Now, Let me first explain to you why alkanes are so non-reactive. The reason alkanes are so non-reactive is because they have a single covalent bond, right? Single covalent bond is not easy to break. A double covalent bond, yes. A double covalent bond is easier to break. A single covalent bond is not easy to break. You need a lot of energy to break a single covalent bond. I literally have to take my fossil fuel and light it on fire for me to break the bonds, for me to let the combustion reaction happen. So alkenes are very non-reactive. Alkenes, not so much. Even your alcohols. Alcohols are also not that, also reactive, okay? Because they have the OH. But the problem with alkenes is that they only have carbon and they only have hydrogen. Okay? And since they only have carbon and hydrogen, and have a single covalent bond does not break easy. Remember this. Single covalent bond, very strong. Double covalent bond, weaker. Triple covalent bond, even weaker. Okay? And why do we see that? That you will study when you do your A levels, you'll study about the bonds and all in more detail. So you'll understand that better then. Why is that? But for now, what you need to know is that single, double, triple. Right? So single is the strongest. Now, over here, we have a single bond, right? So that is really hard to break. That's why alkanes do not react with anything. They don't undergo any chemical reactions except for one. Now, in this reaction, first I'm going to, okay, so in this reaction that I'm going to teach you right now, substitution, I will first tell you the chemical equation. After we go over the chemical reaction equation, you also need to know the mechanism. How is the chemical reaction happening? So we will go over both of them, but first let me tell you the equation. Now, let's say we have methane. Okay? If I take this methane and I react it with any halogen, for example, bromine. What is going to happen? What's going to happen is this, that one of the bromine atoms over here, one of the bromine atoms is going to replace one of the hydrogen atoms. One of the bromine atoms is going to replace or substitute instead of the hydrogen atom. The result is that you will get a compound like this. One of the hydrogen atoms would be replaced by bromine. Okay? And the hydrogen atom will make a bond with a second bromine atom. Bromine, since you have done the topic of halogens, you must remember that bromine is a diatomic molecule. All halogens, fluorine, chlorine, bromine, iodine, astatine, they're all diatomic molecules. Diatomic molecule means that they have two atoms. Inside one molecule of bromine, we have two atoms. That's why the formula of bromine is Br2, right? That's why we have Br2, Cl2, F2, because they all have two atoms. So one of the atoms of bromine will replace the hydrogen. Now this hydrogen, because it has been replaced, it is now free. It will make a bond with the second bromine. And the result is that you will get something like this. Okay? Now, if I tell you, let me tell you the name of this compound. The compound that we are studying is now a new compound that I have not mentioned to you before. The reason I have not mentioned to you before is because you don't have to study this compound in detail. This homologous series, you and I will not be studying in detail this year. That's A levels. But this is methane. Oops. This is methane. This is bromine. Now, the compound that we are getting, how do we write down the name of compounds? Oh, I will also go over with you. In fact, yes, in the next class, I will first explain to you how we name the organic compounds and then we will move on. So, when we're naming the organic compounds, this is how we name them. First, you're going to write down methane. Now, this methane is attached to bromine. So we will call it bromomethane. Okay? We will call it bromomethane. And this is your hydrogen bromide. Okay? So, this is what the reaction is going to look like. Similarly, if I take my methane and I react it with, let's say, chlorine, okay, I will get similar reaction. That's why there are homologous series, because they will always give you similar reaction. So, for example, if I react it with chlorine, I will get exactly the same result. One of the hydrogen is going to be substituted, or one of the hydrogen is going to be replaced by the chlorine. Okay. Now, after the chlorine has replaced, it has taken the place of hydrogen, the hydrogen is now free. That hydrogen, because it is now free, it can go and make a bond with the second chlorine atom. The result is that we will again have something like this. Plus HCl. Now, 2 points that I want to add. First point, when I'm naming this compound again, this is methane. So I'm going to write down methane. Now, attached to methane, we have chlorine. So this becomes chloromethane, right? Then we have HCl. Now, HCl, you must have studied the formula before. It's the formula for hydrochloric acid. But that's not the HCl that we have over here. This HCl is hydrogen chloride. Yes. Now, you might already know this, or you might. When do you call HCl hydrochloric acid, and when do you call HCl hydrogen chloride? You know?
I think I know.
Yeah, go on.
I think we call hydrochloric acid when it is in water, and like
Yes.
hydrogen chloride is when it's not in.
Yes, correct. When it says HCl AQ, right? It's an aqueous state. That's when you call it hydrochloric acid. When the same HCl is in gaseous state, we call it hydrogen chloride. So over here we are dealing with hydrogen chloride. Okay. Now, do you see bromomethane, chloromethane, right? These are now over here. If you look, these organic compounds are now different than alkenes, right? These bromomethane, chloromethane, these organic compounds are different than methane. That is because bromomethane, chloromethane, iodomethane, chloromethane, they are a different homologous series. Okay? They are part of a different homologous series. That homologous series is known as halogenoalkanes. Okay, because they're alkanes, but they have halogen attached to it. So we call them halogenoalkanes. Now these compounds are different than alkanes, meaning that they will further on, they will have different chemical reactions. They will have different general formula. They will have different physical properties. So I can take an alkane, I can react it with a halogen, and the result is going to be that I'm going to get a halogenoalkane. Okay. Now, for this reaction to occur, there is one very specific condition. If that condition is not present, this reaction does not occur. That condition, that really specific condition is UV radiation. If there is no UV radiation, this reaction does not occur. Why? Because halogens are very non-reactive. If you take a methane and you add bromine to it, right now in your laboratory, nothing will happen. Nothing. No reaction whatsoever. You need UV light. Whether that UV light is coming from the sun, right? Whether you're using a UV lamp, doesn't matter, but you need UV light. Once you have the UV, and when I'm saying UV light, I mean like high up in the atmosphere, not over here. In our surface of the earth, we don't receive that much UV light. You go high up into the surface, into the atmosphere, close to the sun, above the ozone layer. That's where the UV light is. So you need UV radiation. This reaction does not occur without UV radiation. Now, in this reaction, one of the major things that you have to know, that you get questions over, is the mechanism of the reaction. So it is really important that you and I study the mechanism. How is the reaction happening? Now, the reaction is happening in 3 steps. Okay. Step number 1 is initiation. Initiation means that the reaction is starting. How does the reaction start? Now, we have methane. We have, let's say, chlorine. Now, what happens that both methane and chlorine have a single covalent bond? I told you a single covalent bond is not easy to break. So how does this bond break? Because of UV
Okay, UV.
UV light, UV radiation is strong. UV radiation is going to break the bond between 2 chlorine atoms. Okay? Now, after the bond breaks between the 2 chlorine atoms, what happens? What happens is this, that we end up getting something that is known as a, free radical. What is a
So
free radical?
UV radiation breaks the covalent bonds between the
Chlorine.
Chlorine.
Yes, chlorine or bromine or whatever the halogen is. Chlorine, bromine, fluorine, it doesn't matter. Whatever the halogen is, it's going to break the double
Only
bond.
for the halogen though.
Sorry?
Only for the halogen, not the alkane compound.
It can also break it for the alkane. That's also a possibility. It can break it for the alkane as well. The point is that it will either break it for chlorine or it will break it for the alkane. The reason I'm using chlorine is because that's what's given in your text, right? But between you and me, between you and me, it can break for the alkane as well. Now, generally what happens is that if you look at the dots and cross structure of chlorine, right? So chlorine shares 1 pair of electrons.
Wait, what's a free radical?
I'm telling you. Chlorine shares 1 pair of electrons. Okay. Now, what happens is that when UV radiation breaks the bond, the chlorine atoms will separate from each other. When they separate from each other, they both keep 1 of the electrons. Over here, in a normal chlorine atom, this is the dot and cross diagram. So in my dot and cross diagram, you can see that chlorine is sharing a pair of electrons. Okay. Since chlorine is sharing a pair of electrons. Okay. Now, when the bond is going to break, one of the chlorine is going to, when the bond is going to break, so each atom will take 1 electron. So first they were sharing the electrons, but when the bond breaks, the UV radiation comes and it breaks the bond. The 2 atoms will separate, but the 2 atoms separate in such a way that they both keep 1 of the electrons. Okay. Now, as a result, what happens? They become free radicals. What are free radicals? Free radicals are chemical species that are highly reactive. They're simply a chemical compound. That's it. Okay. They are chemical compounds that are extremely reactive, like extremely reactive. So what is going to happen that the bond with chlorine is going to break? When the bond with chlorine is going to break, each chlorine atom will say, listen, you and I were sharing a pair of electrons. We have to separate. So I will keep one electron, you keep one electron, and they will separate. As a result, they become extremely reactive. They become a species, a compound that we call free radicals in chemistry. And they are extremely reactive. Okay? Now, what do these extremely reactive free radicals do? These extremely reactive free radicals will do propagation. What is propagation? Now, this is methane. Okay? What happens that one of the free radicals approaches the methane molecule. Okay? It approaches the methane molecule. Now, chlorine free radical. Chlorine on its own, not so reactive. The free radical, extremely reactive. Because it wants to make a chemical bond. It wants to make a chemical bond and have a complete outer shell. So extremely reactive. So it will say, listen, hydrogen, I am extremely reactive. I want to make a chemical bond right now. I don't care where I make it, how I make it. I want to make a chemical bond. So I'm going to kick you out. So I'm going to actually, what is going to happen? I just want a chemical bond. So hydrogen, why don't you go ahead and make a bond with me? Come to me, hydrogen. How about you and I go ahead and make a chemical bond? So I will get HCl, hydrogen chloride. We will get hydrogen chloride. Chlorine will say, listen, come to me. You and I are going to make a chemical bond. Okay? Now, what is going to happen? What is going to happen is that this alkane is now left with one less hydrogen. This alkane is now one less hydrogen. Carbon wants to have 4 bonds. Carbon wants to have 4 bonds, but it only has 3. So now my methane will become a free radical, right? So it's like, it's like a chain reaction. It's like a chain reaction. They keep turning each other into free radicals. So we had a chlorine free radical. The chlorine free radical said, I don't care. I want to make a chemical bond. Hydrogen, come on, right? The result is that now methane is a free radical, right? And as long as there is a free radical, it's literally like a chain or reaction, right? Reactions will keep on happening. They will not stop. What is going to happen? Methane is going to say, listen, now I have turned into a free radical. I want to make some kind of chemical bond. It will see there is another chlorine atom. So it will say, listen, again, it's going to say, I don't care about I don't care about the fact that, you are in part of a molecule. I want you to be a part of my molecule because methane now is a free radical. So it is extremely reactive. So methane will go to another chlorine molecule and it will say, listen, you chlorine, I'm going to break the bond between the both of you and I'm going to take one of the chlorine for myself. I'm taking this chlorine for myself. What is the result? The result is that now we get our chloromethane. It will say, I want a chloromethane, right? But again, now another problem. This chlorine is now left alone, so it becomes a free radical, right? So the reaction will keep on happening. They will keep on attacking each other, right? The UV radiation started everything. The UV radiation started the process. It broke the bond between the chlorine molecule, made them into free radicals. It started the process. Once the process started, now what? They will keep on attacking each other. Chlorine is a free radical. It will attack methane. It will say, I am taking your hydrogen. What is the result? The result is that now methane is a free radical. It lost one of its atoms. Methane is now a free radical. So it will say, fine, I will go find a chlorine molecule. It will find a chlorine molecule. It will attack the chlorine molecule. It will take the chlorine for itself. But again, now we have another chlorine-free radical. This chlorine-free radical will go find another molecule of methane. And the reaction will keep on going and going and going and going and going and going. Right? It will not stop. unless it will not stop unless termination happens.
Wait, so like,
Termination,
I think I
yeah,
did not understand anything in propagation though.
okay. In propagation, so look, what is going to happen is this, that this is chlorine, the free radical of chlorine, right?
Mhm.
This is a free radical of chlorine.
So there
The
are like two free radicals, right? Cl1 and then like Cl, yeah.
Yeah, exactly. So one of them will go for one, like it will go for one molecule. This chlorine will go to another molecule, like that, right? It's like if you look in your surroundings in a gap, there is never just one molecule. There are billions of molecules, right? So
Yeah,
one
yeah.
chlorine would go here, this other chlorine would maybe go somewhere else, doesn't matter. But the point is that this chlorine free radical needs a molecule of methane.
But like,
Okay?
since like Cl is a halogen, right?
Yes, it
They're
is.
gonna have like two atoms, right?
Yes,
Because like of a covalent bond.
exactly.
So they're gonna be two
Exactly.
radicals.
Yes, you will get two free radicals.
Yeah.
Exactly.
Okay.
Okay. Now, what is going to happen that one radical, any one radical doesn't
Yeah.
matter. The other radical can go somewhere else in some other reaction. But the point is that now we have chlorine free radical. Okay. Now, the free radical is highly reactive.
Oh,
Since the free radical is highly reactive, it wants to make a chemical bond. So what it does is it attacks methane. You can literally use the term attack if you want to, it's fine. It attacks methane and it basically snatches, it takes the hydrogen away from methane. It says, listen, I want to make a chemical bond. I want the hydrogen that you have. So think of it this way, that there are kids in the playground, okay? We have chlorine free radical, okay? This free radical is highly aggressive. This child is highly aggressive. He wants to get a toy, okay? He sees that there is a molecule of methane, a child named methane, who has four hydrogen, four of the toys. So he comes and he snatches one of the toys away from him. He is happy. He got the toy, hydrogen chloride, right? The
yeah.
chlorine comes, it snatches the hydrogen away from methane, and now it is complete. It is happy. What is the result? The result is that now methane is left behind with only three hydrogen.
Yeah.
Right? So the result is that now methane turns into a free radical. Chlorine becomes happy. Chlorine gets what he wants. He wanted to make a chemical bond. He made a chemical bond. He made a bond with hydrogen. He's happy. But methane, on the other hand, it lost the hydrogen atom. So now it becomes aggressive. It turns into a free radical, right? So now methane says, listen, I need to go and I just want to get my hands on like hydrogen atom, or not just hydrogen atom. It basically says, I want to go and I want to make a chemical bond. I'm carbon. I'm supposed to have four chemical bonds. I only have three. I want to make four chemical bonds. What will it do? It will go and it will attack a chlorine molecule. This is not a free radical. This is a intact full molecule of chlorine, Cl2. It
Also
will
a
go to,
different Cl2, like a molecule
yeah,
of Cl2.
exactly. So it will go to a molecule of chlorine and it will say, listen, I don't care about anything. I just want to make a chemical bond, and it will snatch away one of the chlorines from the molecule. It will take away one of the chlorines from the molecule and it will become chloromethane. It will become full again. It's going to have all four bonds. It will become happy. It wanted four bonds, it got four bonds. It snatched, it pulled away one of the chlorine atoms and took the chlorine for himself. So now it is complete. But what is the result? The result is now this chlorine is left without the bond. So this chlorine turns into a free
Yeah.
radical, right? So it's a chain reaction. It just keeps on happening and happening and happening. Like this free radical attacks methane, and then the methane turns into a free radical. The methane attacks another chlorine, and the chlorine turns into a free radical. Now this chlorine will go to some other methane and it will start the process all over again, right? So it's
Process
sort
won't
of
stop
like,
then.
sorry,
So this process won't stop then.
this process does not stop. It keeps on happening until you get to termination.
Oh, okay.
How does termination happen? Termination will only happen when two free radicals react with each other.
Yes.
Now, the thing you have to understand is that these are gases. Okay? In gases, there are billions of molecules that are all reacting with each other. Right? So multiple reactions can happen. Right? So one possibility. Now look what's going to happen over here. One possibility is that we have one possibility is that the chlorine free radical. One possibility is that the chlorine free radical can attack methane. That is one possibility.
Huh?
Right? Another possibility is that instead of attacking methane, maybe the chlorine free radical can find another chlorine free radical. That can also happen. Remember, this is gases. In gases, they are randomly colliding with each other. Gases have, if you remember, you must have studied in the topic of states of matter, Brownian motion, right? Which was that they are colliding haphazardly. So all of these reactions are haphazard. They're based on chance. Okay. So is there also not a chance that this chlorine free radical reacts with this chlorine free radical? Right? That is also a possibility. Instead of the chlorine free radical attacking methane, maybe it will find another chlorine free radical and make a bond with it. Termination. Right? No more chain reaction, no more free radicals. Whenever two free radicals join with each other, you get a molecule. The reaction finishes. Similarly, we were getting a methane free radical. What if methane free radical reacts with a chlorine? Because remember, we were getting a chlorine free radical over here. Right? We were getting a chlorine free radical. What if this free radical, methane, reacted with this chlorine free radical? What would happen? Again,
Yeah.
termination. Whenever two free radicals react, the reaction stops.
Yeah.
And what is third possibility? Third possibility is that maybe there are two methane free radicals, because remember, these reactions are happening simultaneously in huge numbers, right? It's not just one reaction. All of these reactions are happening side by side. So maybe one methane free radical can react with the second methane free radical. What's the result? The result is maybe you'll get ethane, right? So the reaction stops. This is termination. Okay. So this is to summarize what is going to happen. First of all, the bond between the chlorine molecule is going to break. Okay. Because of UV radiation. The result is that you will get chlorine free radical. Free radical highly reactive. So the chlorine free radical will attack the molecule of methane. As a result, what will happen? You will get HCl, hydrogen chloride, because the chlorine will snatch the hydrogen away and you will end up with methane free radical. Think of it like this. It's like a vigorous chain reaction, right? This child, this chlorine, let's say he was a bully, okay? He bullied methane and he took away his toy. Now methane has become a bully, right? Methane attacks another molecule of chlorine, not a free radical, a molecule of chlorine. It takes away the chlorine atom, and now the result is that the chlorine has become into the bully, right? So it's sort of like a vigorous reaction. It does not stop until the free radicals react with each other, unless the free radicals react with each other. Now, when the free radicals are reacting with each other, there are three possibilities. Either chlorine can react with chlorine free radical and you can get chlorine gas, or a methane free radical can react with chlorine free radical and you can get chloromethane, or methane free radical can react with another methane free radical, in which case you get methane, right? So this is how the mechanism of reaction, this is how the this is the mechanism of the reaction. And the name of the mechanism, that the whole name of the mechanism is free radical substitution reaction. That's what we call it. Free radical substitution reaction, because these are free radicals and the free radicals are substituting, right? So we call it free radical substitution reaction. And this reaction only happens if UV light is present. If UV light is not present, you cannot break the single covalent bonds and the reaction does not happen. Making sense?
Yeah.
Are you sure? I'm sure you're still a little bit confused. I'm sure though.
No.
The termination, propagation, termination, it's probably still a bit confusing, right?
Yeah, it's little confusing, like no doubt.
Yeah, don't worry. So what we'll do is that we'll stop it over here for today. And next class, we will do this again. Like I will just revise this with you once more to make sure that it's completely clear. And then we will practice questions on the topic of alkanes. Okay? And then when you solve the questions, it will start to become a lot more clearer. Okay?
I like cut out the recordings for this class, so like I can revise again.
Yeah. I've the recordings are on the Google Classroom. I have told we on the academy we have like the manager who adds all the lectures. So I have sent the lectures, like even yesterday's lecture, I have sent them to her, and I told her to upload them. So she said that
But
she'll
like I
upload
don't
them.
think I'm in the Google Classroom thing.
Yeah, I will add you. She has to start. She has to make it, right. She has to make the classroom for you, and then I will add you in it. So I've
Okay.
told her to do that. I told her that I also gave her the recordings from yesterday.